Okay, so let's try this one. The limit of cosine 2x minus 1 over cosine x minus 1 as x approaches 0. Okay, so the same process, gamitin natin ang direct substitution. That is equal to cosine 2 times 0 minus 1 all over cosine 0 minus 1. And cosine 2 times 0 is 0, cosine 0 is 1, minus 1 all over, we have cosine 0 is 1 minus 1. Automatically, that is equal to 0 over 0. So that is indeterminate form. And then, we have to at least modify this function so that we can evaluate the function na hindi 0 over 0 ang ating makukuha. Okay, so cosine 2x minus 1, we all know that in our special limit, okay, in our special limit, we have this cosine, the limit of 1 minus cosine x over x equal to 0. So, we have to use that cosine 1, okay, we need 1 minus cosine x over x. Okay, but this one is cosine 2x minus 1 over cosine x minus 1. We all know that cosine 2x, that is the sum of two angles. Okay, we can rewrite this as, kasi kailangan muna natin itong at least mai-simplify. Kailangan muna natin siya mai-simplify bago tayo mag-direct substitution. Otherwise, we have to use the special limits. Okay, so ang cosine 2x natin ay pwede nating isulat as cosine x plus x. That is a sum of two angles. Okay, using the sum and difference of two angles, cosine, that is cos sin in our identities. So we have cosine x, since that is plus, okay, add an even function, so this is minus. Okay, because cosine is an odd function. Cosine x minus sin x, that is cos sin. Okay, so this is equal to cosine squared x minus sine squared x. Okay, so we can now have this identity para mai-substitute natin dito. So we have cosine squared x minus sine squared x minus 1 all over. Okay, so pinalitan lang natin itong cosine 2x ng cosine squared x minus sine squared x, and then remain ang negative 1 over cosine x minus 1. Okay, so we have now, okay, cosine squared x minus sine squared x minus 1 over cosine x minus 1. And then, we can still have identities, okay, na nandito sa ating numerator. Kasi pwede natin siyang still isulat as cosine squared x minus 1 minus sine squared x all over cosine x minus 1. Okay, so we can still have this one. We can still have this cosine squared x minus 1 is still an identity, because in our Pythagorean identity, sine squared x plus cosine squared x is equal to 1. Okay, transpose this sine squared x on the right side and this positive 1 on the left side. We have cosine squared x minus 1 is equal to negative sine squared x. You transpose this on the right side, so that is negative sine squared x, and this positive 1 you transpose to the left side, that is negative 1. So we can say that cosine squared x minus 1 is negative sine squared x minus sine squared x all over cosine x minus 1. And then this is negative, that will be negative 2 sine squared x all over cosine x minus 1. It is already simplified, but still if you will direct substitute the value of x, that would still be indeterminate. Okay, so what we need is at least we canceled out one of the um, quantity one of the quantities in our function. So we can still have, if we rationalize the denominator, then we have cosine x plus 1 over cosine x plus 1. So we have negative 2 sine squared x times cosine x plus 1 all over, that is the sum and the difference of two binomials. So we have cosine squared x minus 1. And we all know that cosine squared x minus 1 is the one being tawag dito, converted into its identity, cosine squared x minus 1, which is equal to negative sine squared x. Okay, or we can also rewrite this as 2 times negative sine squared x times cosine x plus 1 all over cosine squared x minus 1. Why I have to factor out negative 2 or positive 2 and then factor out negative sine squared? Because I know that cosine squared minus 1 is negative sine squared x. Okay, so the same thing is that you have 2 times cosine squared x minus 1 times cosine x plus 1 all over cosine squared x minus 1, so that I can cancel out this one. So what I have here is 2 times cosine x plus 1. Okay, so getting its limit, so we have the limit of 2 times cosine x plus 1 as x approaches 0. Direct substitution, so we have 2 times cosine 0 plus 1 is 2 times cosine 0 is 1 plus 1, so that is 1 plus 1, so that is 2 times 2, which is equal to 4. And that is the answer.